Welcome to The Explainer. Today, we're diving into a technology that's about so much more than just faster phones. It's about creating a world of instant connection. We're talking about 5G, and we're going to get past all the hype to see how it really works and why it's basically the blueprint for our future.
Okay, so let's start with the big question. Why do we even need 5G? I mean, my 4G seems to work just fine, right? It streams videos, it loads my social media. So what was the big problem that made us need a whole new generation of wireless tech?
Well, the thing is, 4G just can't keep up with the future we're trying to build. Think about things like a surgeon performing a delicate operation from thousands of miles away, actually feeling the feedback through their tools. Or a city full of self-driving cars that need to communicate with each other instantly to avoid collisions. These things don't just need more speed, they need a network that can react in real time, something 4G was never designed to do.
And this, right here, is the heart of the problem. It all comes down to latency, which is basically the network's reaction time. With 4G, you're looking at a delay of maybe up to 60 milliseconds. That's fine for us humans, but for a machine, for a self-driving car, that's an eternity. 5G cuts that down to around 1 millisecond. That's pretty much instantaneous, and that is the real game changer.
So get ready for this, because the goal the engineers set for 5G was, well, it was kind of insane. They weren't aiming for a small boost. They were tasked with increasing the entire network's capacity by 1,000 times. That's just a mind-boggling number.
1,000 times more traffic. You have to ask yourself, how is that even possible? I mean, we're already bumping up against the fundamental laws of physics here, something called the Shannon limit, which sets a theoretical speed limit for how much data you can send. So, if you can't break the laws of physics, how on earth did they pull this off?
Well, it turns out the answer was pretty brilliant. Instead of trying to find one single breakthrough, they attacked the problem from 3 different angles. They figured out how to get 10 times more bandwidth, how to make that bandwidth 10 times more efficient, and how to make the network itself 10 times denser. And what do you get when you multiply 10 by 10 by 10? You get 1,000. So let's break down how they tackled each one.
All right, let's start with the first piece of this puzzle, and it's a huge one. It all begins with completely reinventing the antenna.
This is a technology called massive MIMO. Now, instead of a couple of big, clunky antennas on a cell tower, a 5G base station has an array of hundreds of tiny ones. And this huge army of little antennas is what unlocks a really powerful new trick.
And that trick is called beamforming. This is where 5G gets incredibly smart. Rather than just blasting a signal out in every direction hoping some of it hits your phone, the network can create a concentrated, focused beam of data and aim it right where it needs to go.
Okay, this is probably the best way to picture it. Think of a 4G tower as a bare light bulb in the middle of a room. It's spraying light and energy in all directions. It's wasteful, and it creates interference for everyone else. But 5G's beamforming, that's like a high-powered, laser-focused flashlight. It points all of its energy in one tight beam directly at your phone. You get a much stronger, cleaner signal, and it doesn't bother anyone else.
And when you have that many antennas all working together, a couple of almost magical things happen. First, the signals going to different people naturally sort themselves out and stay in their own lanes. So no more wireless traffic jams, no more interference. Second, the connection itself becomes rock solid and predictable. It's almost as reliable as if you literally plugged in an Ethernet cable. No more random signal fading.
But, having all these smart antennas isn't enough. You need an equally smart network behind the scenes to control everything. The whole system had to get way more intelligent and a lot more flexible to handle this new world.
And that's where this incredible idea called network slicing comes into play. Just imagine the entire internet is one big highway. What network slicing does is let you create multiple virtual private VIP lanes on that same physical highway. And each of those lanes can be totally customized for a specific job.
And this is just so cool, right? An autonomous car gets its own guaranteed, ultra-reliable, low-latency lane. A whole city's worth of smart sensors gets a different lane, designed just for low power and tons of connections. And you, streaming a movie, you get your own high-speed lane too. All of it happening at the same time on the same infrastructure. It's a total game changer.
So how is this even possible? Well, it's because they totally re-architected the network. They essentially separated the brain of the cell tower, the part that does all the processing, from the antennas that actually send and receive the signal. And they're connected by these super-fast fiber optic rings. This separation is what gives the whole system its incredible flexibility.
Okay, so 5G is already blowing our minds.
But you know engineers, they never stop. They're already dreaming about what comes next. And let me tell you, the ideas they're cooking up for 6G are straight out of science fiction. So get this, reconfigurable intelligent surfaces. We're talking about making the walls of a room or the paint on the side of a building an active part of the network, able to intelligently reflect signals to get rid of dead spots. It's just wild to think about.
Or how about this? Cell-free massive MIMO. This takes that 5G idea and just blows it up. The whole concept of a cell, of being connected to one tower at a time, just goes away. Instead, you are seamlessly connected to all the antennas around you, all working together as one giant intelligent system.
And just when you think it can't get any crazier, it does. With these enormous antenna arrays, we could go from steering a beam to focusing it, like on a single point in 3D space. The possibilities are insane. We're talking about truly unhackable communication, maybe even wirelessly charging your devices just by having them in the room.
So when you put it all together, you really see the big picture. This isn't just another small step up like 3G to 4G was. It is not an evolution. It's a full-blown revolution in how we think about wireless communication.
So at the end of the day, why does any of this matter to you? Well, because 5G is so much more than faster downloads. It is the literal foundation, the operating system for the next wave of technology. It's a whole new environment for innovation, and honestly, we're just beginning to scratch the surface of what we can build on top of it. Thanks for joining me for this explainer.